This is our second friction video, and it's solving for coefficients. And these are probably some of the hardest questions we do in the class, at least as far as calculations are concerned. These two equations, you'll want to have them written down. Though really they're just rearranged forms of the equations I already gave you, like Fs equals mu s times Fn. This is just a rearranged form of that. Same here. So this is finding the static friction coefficient. This is finding the kinetic friction or sliding friction coefficient. And we'll do a couple of examples doing that. And as we do this, I want you to think a little bit about my bonus question for you. Because if I gave you two pieces of aluminum, could you figure out a way to solve for, I want to see this one, the kinetic friction coefficient? So think about that as you go along. You have labs solving for coefficient, so the process that you try, I think the one, and I give you the steps on how to do it, finding the coefficient of friction, I think it's between your shoe and the lab bench or something. If you do that, and you say, well, okay, once you know that, maybe you could figure out how to apply that to aluminum on aluminum. I'll just give you that challenge, because I don't think it's 1.4, I don't buy it. Anyway, so in this case, our example, we're looking at static friction, okay? So it says, Batman would like to know the coefficient of friction between the Batmobile tires and concrete. So he applies a horizontal force of 10,000 newtons. When he does that, he can just start to slide. That just start to slide line right there, that is the key to me that you're looking for, you're dealing with static friction. It tells me that this must be Fs. Okay? We know the mass of the Batmobile. And so it's asking for the coefficient. So the steps that you follow is we draw a free body diagram, we find Fs, and I told you we know that because it's going to be equal to Fa, because that's just start to slide. We need to find the normal force, and then we can use the formula for the coefficient. So looking at my solution here, here's the information we're given. Fa equals, that's how much he applies. Like I said, it has to, because that's what it takes just to start it moving, it has to be equal to Fs. Okay? The free body diagram, here's the Batmobile, Fg is down, of course. Normal is going to be equal to Fg because there's no other forces, right, on the up-down direction. And same here. Fs has to be Fa because that's what you applied just to get it going. Okay? So once you know Fs, and we do, then we can find normal because it's going to be equal to mg, so it's 18,130. So quite a few steps, right? All you're asked to find is the coefficient, but you can't just take the numbers and do that. You need to do a few steps. First figure out Fs, then figure out Fn, and then of course you can use this formula and solve for mu s. And I know it's a good number because it's between 0 and 1. Okay, so there's the general formula, sub n Fs, sub n Fn, do the divide, and you get the answer. Okay? That's solving for coefficient of static friction. We're also going to do an example solving for the coefficient of kinetic friction, and you'll see it's really the exact same. You distinguish by the question. So this one said just starting to slide. It's got to be Fs. The next one we're going to do is finding sliding friction or kinetic friction, and there it's saying constant velocity. And this is important, by the way. When you do your labs, you have to be at constant velocity to find the coefficient, because you need that applied force to be equal to the kinetic friction force. And if it's accelerating by slowing down or speeding up, they won't be equal to each other. So in order to find coefficient of friction, you need to be at constant velocity. And so this question is saying, well, Batman is moving at constant velocity by applying that much force. So that's his applied force, but it's got to be equal to the kinetic friction force because it's constant velocity. Forward force will equal the backward force. So looking through the solution here, I'm going to treat it exactly like the static friction problem. And like I say, we can say Fk equals Fa. So there's my kinetic friction force. You need to have that to find the coefficient. Fn is the same as the last question. Still the same Batmobile. That doesn't change at all. So when you solve for your coefficient then, you just divide out Fk by Fn, and you get 0.44. Again, we know it's a good answer. We know we did well. We did good physics because it's between 0 and 1. Okay, so like I say, those are two of the hardest ones, and you'll probably have to refer back to this or refer back to your notes when you try solving a couple of these questions. Expect to see one on your test, so they're worth reviewing again before you have test day.